Good night, sir.
Dime aquí, y yo, Nico, hold on. Mikey, are you hearing me? Nico, Asia, hearing me?
Even sir.
Okay. Mikey, you were saying something?
I said, I'm hearing you.
Okay, okay. Nico? Okay. So I was on the road and I picked up your message, Mikey, so I never get a chance to action it, but I'll definitely action it for you. Um,
Okay, so no problem.
mhm. All right, so are we all ready for the exams that are coming up? Or getting ready at least?
Starting, yeah, man, the preparation has started.
Nice. Very nice. I depend on you guys. I depend on you to do well. You have one or two courses that are not not will be tested on examination, but for coursework only. Maximize on those one, please. Give me half a second, please. All right, sorry about that. What was I saying before I left again? Forgive me. Oh, I may have been encouraging you to just make sure that you're duly registered. If you're having any difficulty, tonight is the last night that you need to speak to me about it. Exam begin a week from now. All right. And Mike, I need to just send a gentle reminder to the assessment services unit. Have you sorted out your proctor already, Michael?
Yes, sir. I've submitted that from I think it was last month, at the beginning of this month.
Mm-hmm.
Same proctor I'm using, so it shouldn't be an issue.
Mm-hmm. All right. Okay. So as promised, I said to you that I'm going to be moving on into something else. I was making some notes for you earlier today. And by the way, final thing before we begin. This question is for everybody else away from Michael. Was today very hot?
Sir, everybody else.
No, man, Asia. I was in a class today, and honestly, I couldn't go. Students asleep. I get miserable. I said, no, guys, this is it. Have a nice day. Couldn't breathe.
Sorry, you mean to the cold?
Mm.
To the cold, the state turn on but the heat today. No? Something
Mm.
really happening. Yeah, we're in the middle of spring and the heat is back on.
What's the temperature like?
It's down to 50 in the 50s, lower 50s.
I want to slap you with that statistics book. All right, that's what I want to do.
No
Slap
man,
you silly.
normally, them time here when I get like 70s. It will only reach 70 about one day. After that, it's gone back down to freezing a few times.
I want to slap you silly. That's what I want to do. All right. I want us to look at the Poisson distribution. We looked at the binomial distribution. Anybody can remind me when we use the binomial distribution again? Binomial distribution is used when we have what?
Two variables,
Yes, two variable. One is
X and Y, or A and B.
two variables. One is something and the other one is something. Asia, come. Mm?
Sir, just getting, one independent, one dependent.
Yeah, independent and dependent.
Mm, mm, mm.
Sir, two possible mutually exclusive outcome.
Get a little bit more granular for me. A little bit more granular. In short, in layman's term, one is
Success and failure.
mm-hmm. Success and failure. Everybody see that? So the binomial distribution talk about success and failure. So I may say to you that the probability that it's going to rain is 0.7. That's success. What's the probability that it's not going to rain?
0.3.
0.3. Yeah, 0.3. Very good. Yeah. So how do you know when to use the binomial distribution? When you read a question and there's one that says success and the other one that says failure, it may not come out as success and failure. It may say that the probability of me passing an exam is 0.9. That is a success. The failure is going to be 0.1. It may say that the probability of a red car passing is going to be 0.2. The probability of it not passing is going to be 0.8. So yes, Mikey, it's two variables. If it is one, it is that we're going to subtract that from the probability, the sum of the probabilities, which is going to be equal to 1 in order to get the other one. All right, so think about it like that. One is success, one is failure. The Poisson distribution now, how you know when to use a Poisson distribution is what I'm outlining here. So we're going to have a little conversation. Then I do one question with you. And then we'll see if we can, you know, tie it in nicely. I'm not going there. We have the normal distribution also to look at. Also have the normal distribution to look at. It says a Poisson experiment is an experiment that has the following properties. The Poisson experiment is an experiment that has the following properties. The number of successes in the experiment can be counted. The number of successes in the experiment can be counted. Now, the mere fact that I say that the number of successes in the experiment can be counted, when you can count an experiment, it means that it is going to be discrete. When something is discrete, it means that it can be counted. So the number of successes in the experiment can be counted. The mean number of successes that occurred in a specific interval of time or space is known. So the mean number of successes is also known. The mean of the success is also going to be given. And each outcome is independent. Each outcome is independent. It doesn't depend on another thing that is occurring for me to have that outcome. The outcome is independent. And also that the probability that a success will occur is going to be proportional to the size of the interval. So what I want you to do for me is I want you to read these 4 conditions again for yourself. And then I'm going to give you a further explanation as to what those 4 conditions are talking about. So read those 4 conditions for me to yourself. All right. So again, the number of successes in the experiment can be counted. The mean number of successes that occur during a specific interval of time is known. Each outcome is independent. Means the probability of something happening is not dependent on another variable or occurrence. It is going to be independent. And the probability that a success will occur is going to be proportional to the size of the interval. So if you have a larger interval, the probability is going to be greater. If you have a smaller interval, the probability is going to be less. So the probability of students fighting in the transportation center is going to be increased because you have lots of students congregating in the transportation center. They're not using the transportation center as a hub, meaning to get there, to jump on a bus to go about their business. They are going to be congregating. You know how students are. They may see somebody dressed in something or, and they pass a comment. You know how young men are. They may see a girl and want to say something to the girl, and the girl maybe in the presence of her little boyfriend, and that's where you have the war starting. So the probability that the success will occur is going to be proportional to the size of the interval, right? The larger the size, the greater the probability of it occurring. Understanding so far?
Sure. So are you you're saying so the larger the interval, the greater the probability?
Mm-hmm.
So why is it like that and not when the intervals are smaller? Because it would have been more frequent.
Put it this way. If you have a small hospital, you may have very few births per day. But if you have a larger hospital,
Speaks the capacity.
ah,
Okay. Okay.
mm-hmm. So, yeah, can look at it like that. So one example of the Poisson experiment is the number of births per hour at a given hospital. For example, suppose a particular hospital experiences an average of 10 births per hour. This is a Poisson experiment because it has the following properties, 4 properties. Remember, when we speak about the binomial distribution, as you know from the binomial experiment, that is A or B. And remember, one of the things when you're doing pre-calculus, we said that if A occur fully, there is no B. But as soon as A descends 1, B ascends 1. True or false? Yeah, no, do you remember?
Yeah, because once you have to balance out the power, yeah.
Very good. And the sum of the power is supposed to be equal to the overall power. Remember them things there?
Yes, sir.
Good. So these are the 4 things. So the number of successes in the experiment can be counted. Remember I said to you, the number of successes in the experiment can be counted. So the number of successes can be counted. We can count the number of births. So in the hospital, they can count the number of births. So we're looking at it. Let me go again. One example of the Poisson experiment is in the number of births per hour at a given hospital. So for example, suppose a particular hospital experiences an average of 10 births per hour. The Poisson experiment can be used because 1, the number of successes in the experiment can be counted. I can tell you that there are X number of births in the hospital, so we can count the number of successes. It says the mean number of successes that occur during a specific time interval is known. So we know that it's 10 births per hour. So we know what is happening. It could be births or it could be deaths. Could be admissions. It's just that we know the mean number of successes. Each outcome is independent. No, the probability that one mother gives birth during a given hour is independent of the probability of another mother giving birth. So one mother say, okay, you first got have baby, and then after that, no, me go on the bed, I'm gonna have baby. No, when baby ready to come, baby, I come. True or false? Do I have any mothers here? Have you ever heard of anybody trying to suppress the birth of a baby? When the baby ready for come, what's gonna happen?
Be ready for coming, come. You can't stop
And listen to me. Baby have no behavior. I saw something on TikTok. And I mean, I think the app is very beautiful, but there are some things about it that, you know, really get at me. I saw something on TikTok where a mother, an expectant mother, works with a delivery company, and, you know, I don't want to call them name, but, you know, one of those famous ones that you can just, you want something, you just go on and just buy it and them come and them deliver it in these boxes. Yeah, you know what who I'm talking about. And she was walking the box to a house, just come out of the truck. And then when I saw the video, I was wondering, oh my goodness, somebody just held her up. But the lady just went down on her knees and then she just started to cry out. And apparently, the residents of that particular house heard the cries and came to the lady and she said, my water just broke. And I was like, oh, darn, that child has no behavior. And I put in a bonnet. Don't bonnet and don't have no behavior. And right there and then, she says, oh, no, I can't hold it. And the strangers had to be taken off the woman's pants. No, that is assault. It is assault. They had to pretty much strip her right there. So the residents had to run in, get towels spread, call 911, and whatever the situation is. And while they are waiting, the baby decides, I am ready to come out. So each outcome is independent. Not all, and I have heard of stories where baby born in a taxi. The other day in Jamaica here, a police officer assisted a woman in giving birth, right? Unfortunately, the police officer did pay attention in first aid class, and he was able to give to assist the lady right here in Jamaica. I saw it in the media to give birth. So that, and I'm giving you these examples so that you can remember each outcome is independent. The probability that one mother gives birth during the given hour is independent of the probability of another mother giving birth. And finally, the probability that a success occur is proportional to the size of the interval. It's the same thing, you know. The probability that a success occur is proportional to the size of the interval. The longer the interval of time, the higher the probability of that a birth will occur. Right? The longer the interval of time, the higher the probability. So I mean, if you talk, we talk about 10 births per hour. If you're looking at the interval of time now to be 20 hours, you expect more babies to be born. True or false? True. Yeah, man. Right? So the probability that a success is going to occur is going to be proportional on the size of the interval. So these probabilities, these conditions rather, must be known. And what are the conditions? The number of successes in the experiment can be counted. Discrete, not continuous. It can be counted. All right? 2, the mean number of the successes during a specific interval of time is going to be done. For example, 10 births per hour. And then each outcome is independent. One pregnant lady not going to say to the other pregnant lady, wait on me so that the both of us can have baby at the same time because you and me are friends. Oh no, baby ready to come, baby going to come. And the interval of time, once the probability of success will occur, is going to be proportional to the interval of time. So the longer the time period is, the more successes you expect to occur. All right? Okay. So now we can, by the way, are you following so far?
Yes, sir.
Yes,
All
sir.
right, good. Let me pause right here. So so we can use the Poisson distribution to speak about, say, for example, the number of students who will sit the environmental studies exam and pass it. Because we can know the number of successes. True or false? Can those be counted?
Yes, they can.
Right. The mean number of successes during a specific interval of time is known. We know whatsoever in that particular sitting. Each outcome is going to be independent. The success of of a student passing a course is going to be independent of other. How you know, sir? Because the students are not allowed to communicate during an exam because of invigilators. All right. And then what I can do now is speak about looking at increasing the number of students for argument's sake, or maybe looking at the number of students passing the environmental studies exam for one class compared to increasing the interval, looking at 2 classes. Does that make sense? It says the probability that our success will occur is proportional to the size of the interval. So I could looking at the probability of, say, form 1, but I could also look at form 1, say form 1W, say it's Woolmer's, form 1W. I could look at form 1O, or a form 1L, or form 1M. So it means that the size of the interval is going to be increased. Does that make sense?
Because you're adding more classes.
Right. So increasing the interval. So it's just like increasing the time moving from 1 hour or 10 hours to 20 hours. Yeah, so it's increasing. So we can use the Poisson distribution to answer the questions about probabilities regarding the Poisson experiments, such as what is the probability of more than 12 birds occurring in a given hour? The probability of less than 5 birds occurring in a given hour? Or what is the probability between 8 to 11 birds given a given hour? Because there are several conditions that you're going to know. You know the number of successes, 12 birds. You know the mean number of successes is going to be 12 birds in a given hour. Right? You know that is going to be independent. The number of birds is going to be independent of the other one. And of course, you know that the probability that a success occur is proportional to the size of the interval. All right, so the Poisson distribution describes the probability of obtaining k successes during the given interval. What's the difference between the probability, the Poisson distribution and the binomial distribution? I have a friend who says to me whenever it's time to mark exam papers, funny story. That friend that has become a very good and close friend of mine to this day is a past student of mine from the institution who studied environmental studies at the college, who I had the privilege of teaching pre-calculus to, was in associate degree, and teaching environmental stats to at the bachelor's level. And every time I'm going to mark, I mean, since the person would have left, you know, every time I'm teaching, and I say, oh crap, you're the problem, I'm gonna mark some papers here. Them say, we can't help you, you know. I said, no, sir. It's the grace of God that helped you with the math for your associates and your bachelors. So no, it's all right. Them said easy. Is that right or it wrong? I said, no, if I didn't mark your paper like that, you'd have still in the program. You have to look to see if you're partially right. Him say, no, it's right or wrong. I say this to say to you, right or wrong is going to be the binomial distribution. Success versus failure. 2 cut. So when you read the questions, you will be able to decide. And sometimes the questions will tell you what to do. You know, it will make mention of binomial in it, or it may mention of the Poisson distribution. It may mention of the normal distribution, right? But as you mature in doing the questions, you'll see the difference and read the question and know how it is that you can work it. All right. So the Poisson distribution describes the probability of obtaining k successes during a given time interval. Now, hear this now. So if a random variable x follows a Poisson distribution, then the probability that x, which equals to k successes, can be found using the following formula. Right? The probability of x equals to k successes is going to be lambda raised to the kth power times e to the negative lambda and all of that is divided by k factorial. Take a minute and digest that formulation. Every single time we are using the Poisson distribution, that is a formula we're going to be using to evaluate the distribution, the probability of the distribution. Every time we're talking about the Poisson distribution, that's the formulation we're going to use. Take a minute just to look at what is happening right there.
So you said that
Right?
sign there is lambda, it means?
Yeah, that's lambda. Yeah, say it again about lambda.
No, I just wanted to make sure that I got the name lambda.
Mm-hmm. And don't be surprised. Lambda is just one little something. It has a specific function. So from a read the question, and you get what lambda is, it's no biggie. Lambda has one specific function. You don't have to calculate it. Then I'm going to tell you what it is. All right. So the probability of x, which is equal to k, is going to be lambda to the kth power times e to the negative lambda all over k factorial. So it's the same set of numbers in the question that we're going to be playing around with, just to substitute it to the formulation. Now remember, k factorial is going to be k factorial times k minus 1 factorial times k minus 2 factorial times k minus 3 factorial, all the way down to n. Can you remember that? For example, 5 factorial is 5 factorial times 4 factorial times 3 factorial times 2 factorial times 1 factorial. What is 0 factorial equals to?
Not. One.
Okay. So 0 factorial is going to be equals to 1. So the factorial is just you multiply by these numbers every time I subtracted 1 from it. So 4 factorial is 4 times 3 times 2 times 1, right? So those are just what it is. All right, so let's go. See, lambda has a specific name. It is going to be the mean number of successes that occur during that specific interval. Lambda is always going to be the mean number of successes. You will know from the question the mean number of successes that occur during a specific interval. K is going to be the number of successes. Remember, it is discrete. Uh-oh, what do you mean by discrete, sir? You can count them. You can count them. The number of successes in the experiment can be counted. The number of successes in the experiment can be counted. All right. So, so there's a question in the chat. And it's a question that I've often asked my teachers. Didi, I have seen a mathematical proof to it. I can prove it to you. But it's when it distracts away from just understanding what the Poisson distribution is asking us to do. So at this stage, all I'm going to say to you is just agree that 0 factorial is going to be 1. What is 5 through 0? 5 through 0 equals what? Work on a calculator and tell me what 5 through 0 is.
1, sir.
What is 5 through 5?
1, sir.
1. So when I was doing this thing to Dan, when I was learning binomials, me ask the same question. You explain to me, teacher, why 0 factorial is 1? Just like you done, 0 times anything is 0, sir. But that is, and we've had many a math conversation around it. Why is 0 factorial 1? Explain it, verbalize it. And if you really ask 1 or 2 math teachers, them going to say, me don't know them, just tell me. And me believe it, because when you put it on the calculator, you get 1. But I guess we can have, we can have 1 or 2 bit of conversation on it. Let me pause right here as you try to soak in the information. I have been a little bit more than generous with you in terms of how I presented the information in biteable sizes. And I did that particularly because I wanted you to understand what was going on. I spent an awfully long time on the measures of central tendency for showing you how you calculate the mode, the mean, and the median for grouped and ungrouped data. And equally, I spent quite a bit of time looking at our coefficient correlation. So I am now, and because those are heavy questions, the questions that will come on the Poisson, the normal, and the binomial distributions, maybe about a 5 mark each, or maybe a 10 mark, as opposed to the other questions that will come for a greater percentage of the marks. I'm expecting a full question come exam day on coefficient and correlation coefficient, right? I'm expecting a full question. So in such a case, I have to spend more time on it so that you can understand it better. So as a result of that, this is why I won't even call it a pickle, but this is why it is that we're doing what it is that we're doing now. I say this to say to you that I have just a few more things to do, to the point where I'm going to meet you 2 more times next week. I know you're supposed to be on your study break, but what I'm going to be doing with you, it can be used to help with the preparation of your studying, so to speak. And coupled with that, at the top of the week, I need to give you your mid-semester. When I say top of the week, it could be Tuesday. I'll give you your mid-semester. And of course, your mid-semester is going to be, so you have to start the preparations. Your mid-semester is going to be on areas that will also come into the final examination. So the aim for me is to give you the mid-semester mark, so that when I can give them back to you at the second sitting of us meeting next week, so that you can know what percentage you're going into the final exam with. I'm a stickler to that. I think students should know what it is that they're playing around with. Yeah, so that is the order of the day for next week. My other groups, I would have completed. Today was my last with my day calculus group. Tomorrow I have a 69 class that I'm going to finish off with my calculus 2. I'm being a little bit generous with. I will finish off next week, but just to give you an opportunity to see what these questions are like, and get the mid-semester out of the way, and just help you pretty much to get these preparations out of the way. I'm going to ask again, I'm going to implore you, you have to, you're not getting a formula sheet in the exam. You're not getting a formula sheet in the exam. So at some point in time, make sure that you remember what the least squared regression formula is. Remember what your product moment formulation is. Remember what your mean, mode, and median formulas are, because you are going to be needing them. Also remember what your binomial distribution function equation is. Remember what the Poisson distribution is. So all of these things you must know. And I'm going to implore, I'm going to beg of you. I see that you guys are moving a little incrementally on Edgarsoft. I was there last night doing some stuff. I got 1 or 2 requests today. I've not yet gone back on since, but I will definitely go to amend or to effect some of those requests. But please, guys, complete your work online. I will try and facilitate it right up to the end so that I can give you the best opportunity in passing the course. Okay, with that said, let's continue. Any questions?
Sir, even I just do the factorial where order is important
Mm-hmm.
and with 0 and it still get 1.
Mm-hmm.
And
No, man, it's going to be online, done. It's going to be online. No, definitely online. Yeah, man. So that is a very special case. As I said before, so special that I'm going to see if I can simplify it for the next the next time we meet, or I can simplify it and drop it in the WhatsApp group so you can see and explain, understand why 0 factorial is just 1. Very special. Very, very special. Oh, so I asked a question earlier and Benika answered. When I said 5 through 0, yeah, man, it's going to be 1, because remember 5 through 0 is going to be 5 factorial over 5 minus 0 factorial, 0 factorial. That's the formulation, you know? So NCR, we have that to look at also. But I'm not worried about that because I know you did that in pre-calculus. I'm leaving that to the very end. NCR is going to be n factorial over n minus r factorial, r factorial. Are you following what I'm saying? Let me write it. Let me write it, because that also, Benika just told me because she put it in the calculator. But I want to write it so that you can see what it looks like. And that's true. No positive value is less than 0. Yeah. That is very true.
Hey, afternoon, sir. Sorry for joining your class late.
Yeah, man, no problem. I hope you're all right, though.
Yes, sir.
All right. So what I asked earlier was, 5 choose 0. And the answer is 5. Now, that's when you put it on the calculator. You know, you get that stuff. But recall, NCR is going to be n factorial over n minus r factorial times r factorial. NCR is n factorial over n minus r factorial, r factorial. So 5 through 0 is going to be 5 factorial over 5 minus 0 factorial, 0 factorial. So that is really going to be 5 factorial over 5 factorial, 0 factorial. And the two always have it 6 o'clock gone at evening versus at night. I watch the whole of the semester. The whole semester. Pause, please. Just get it now. Just get it. All right. And so by the time you leave this session, you know when at night versus when at evening.
Yes, sir. I'm going to try remember.
All right, good. or from evening past the afternoon. You're unkind, DD. All right. So in this case, watch a 0 factorial. That's 0 factorial 1. Because if that 0 factorial is going to be that 0 factorial is going to be 0, that means when I'm looking at the coefficient 1, 5, 10, 10, 5, 1, it means that this here would not take charge, because I'd have a 0 right here. So it would have defiled the whole positive values of our data set. All right. Okay. Let us continue. Excuse me. So one example of the Poisson is going to be hold on there. What is happening here? All right. Okay, so, and then now, K is going to be, of course, the number of successes, and E, you know what E? That's a natural logarithm. And that has a constant value of 2.71. So if you press E on your calculator, tell me what value comes up for E. That's supposed to be over ln. And tell me what value you get when you press E on your calculator. Anybody? Somebody?
Sorry, cube above my ln.
What is above your ln?
Cube.
Cube?
Cube.
Or cube?
I see e to the x over my ln.
Right. So put E to the first power. So E, just press E and then press 1, which is the same thing as E, and tell me what you get.
We get 1.
What?
Hold
That
on,
calculator of yours.
no, maybe I did it wrong.
It should be E to the 0. E to the 0 is 1.
Sir, I think my E is where the cost sign is.
Mm-hmm.
So what I press oh, alpha something.
Mm-hmm.
Oh, sorry, when I press E, I'll take it.
Mm-hmm.
I got 2.7182.
Mm-hmm. Mm-hmm. I cannot just wait in a Michael because he may have forgotten in the cold go get a decent calculator.
Oh, sir, I'm not find the e. I want a different e.
No man, E man.
Oh.
Look where it may say E to the X.
Yeah.
Yeah, but
So
it's
all
a
you do,
different function.
you press E. When the E function come up, you may see the E function on the calculator, you may not see it. But when you press E, then just press 1 and then equal.
Oh, sorry, remember, so I have to do it in the reverse. So I get 2.718281818.
Okay. So you know where to find it now. When you or your calculator stay.
Sir, no calculator, driving.
Oh, okay, got you. All right, now. So we know all of that. So now, for example, suppose a particular hospital experiences an average of 2 births per hour. Right? So I'm creating a scenario. And I want you to work with the scenario with me. I also want you to hold the calculators in your hand. Vanika, you hold the steering wheel if you're driving, if you're being driven. You can hold the phone and look. Half a second, please. All right. So for example, suppose a particular hospital experiences an average of 2 births per hour. We can use the formula above to determine the probability of experiencing 0 or 1 or 2 or 3 support and so on births in the given hour. All right. So remember, this here is very important. Lambda to the k times e to the negative lambda divided by k factorial. So you see why it is that I had to stop you and ask you to find e on your calculator? Because on your calculator, the calculator is built in to show you what the value of e is. So you're going to put e to negative the value of lambda. But oh, sir, what lambda is again? Is a mean. It's a mean number of successes. So the same value that you get right here, so is the same value you get here, so but it's just that it as a negative. K is the number of successes. So how many successes you have is right here. So, but it is also the same K right here. So you see, you have the information, there's a play around with a formula. So I'm saying to you that the Poisson distribution is not difficult. That's the point I'm trying to get at. You have two sets of values. And those two sets of values, you can play around with a formula and use it. All right, let's go. So if we have the probability of, oh, and incidentally see here, lambda to the x power, lambda to the x power over x, lambda over k factorial, lambda, this 0 is going to be the same 0 as 0 factorial. And this 2 is going to be to the negative 2 because that's lambda. That's lambda. And that's my x, or I could my k factorial. All right. You have variations to the variable that they use. See, k, some books use it as x, but kx, same difference. Kx is just a number of successes. All right. So now let us go. What I want you to do is to try this on your calculator to see if you get this this evaluation. Matter of fact, let me not even cover up the rest. I'm going to go up all the way up to 3. Put in all of those for me. I'm stepping away for 2 seconds. Put in all of those and tell me if you get the calculations for those. Pick and pass.
Let me see. Um, one, two.
You guys get it?
Yes, sir. I get them.
Nice. Asia, get it? How's it get it?
Yes, sir.
Sir, I'm
Alright.
not sure how to plug in all of those things, sir.
And that's the point I'm making. So you need to know because I have a question to give. If I can't give it in, if I can't, do I have enough time in class to give it to you? I'm going to type it up and send it off to you so you can play around with it. So you need to know, Papa. So that's why I'm giving you the groundwork in class. I have another example so we can look at. So come talk to us.
So you're starting from what? 2
2 to the 0. Somebody can tell me the algorithm, please.
the the upside down V
Right. Yes.
with 0.
Right.
And then what's the
Times
well, that's times.
and
And then
then
you have your E.
the E
Yeah.
and then the same upside down V to the -2.
Mhm. Yeah.
Matter of fact, scratch that. I'm going to show you how to put everything in the calculator one time because how I told you a while ago, you have to go get one answer and then do something else. So do me have to start over again now. You can
Mhm.
open your parentheses,
Mm-hmm.
2 upside down V.
Yeah.
Oh, you may have it this way. 2 upside down V 0
Mm-hmm.
times E upside down V -2, close parenthesis, divided by 0 factorial equal.
Well, how you get the factorial?
Look at the top left-hand corner of the shift. The shift button normally has the factorial to it.
All right. So I seen
Look,
a button that says
an exclamation sign is a factorial button. If
I
you
see
look to
a
the right,
X with an exclamation.
yes, the X with the exclamation is a factorial button. Yeah.
Yeah, I see it. Yeah. Yes, sir.
When you press equal, what you get?
The 0.135.
You sure?
One.
Sir, I'm not getting the last one.
Try it again, man. Supposed to get
My
it.
owner says syntax error.
Shouldn't be. DD says she gets it. Asia, you got it?
Sir, may I redo it and test the syntax error as well?
All right, don't put the parentheses there. Don't put the parentheses there. Remove the parentheses. And what answer you get for this? 2 to the 0 times e to the -2. What answer you get?
That's the same thing. Let me try.
See, syntax error?
Yes, sir.
Oh, so I tried it again without the parentheses and I got the answer.
Right. That's why I say remove it. Sometimes that can happen. Don't put the parentheses pass. Remove the parentheses.
All right, sir. So 2 to the 2 to the 3 would that equal to 8, right?
Always.
And e to the -3 will give you 1.253, right?
E to the -3.
Yeah.
All right, let me tell you that's in a few.
No, e to the -2, sorry.
No, e to the -3 is what?
0.1353.
Yeah.
All right. And you divide that by 3 factorial.
Yes, sir.
You have to put in the question mark with when you're doing it.
Yeah, that's what the factorial is. So when they put the question sign, that's why it knows that it's going to be 3 times 2 times 3 times 2 times 1. So if it does divide that by 6, because 3 factorial is 6, divide that by when you multiply the 0.1353 by 8, you can get 1.0826. And if you divide that by 6, you can get the 0.1804. Why 6? Because 6 is 3 factorial is equal to 6. How no? It's 3 times 2 times 1. 3, 2, 6, and 6 times 1 is equal to 6. So if you have 8 multiplied by 0.135, 335 time divided by 6, you're supposed to end up with this answer here.
Oh, I get 4 instead of 5.
Oh yeah, that's fine. That's fine.
I didn't know
But-
that I had to do the
well, I actually got the same 4, and I got, yeah, that's true. I get 0.180447. You didn't know you have to what? No, Michael? Mikey? You gone?
I was I was muted. No, I was saying that I was doing it both with the calculator and manually.
Yeah.
Yeah. So
Yeah,
I
yeah,
was
yeah.
getting it manually, but I wasn't getting it on the calculator. I
But you get it
realized
on,
that, I had to put in the factorial. That's why it wasn't going in.
right. Yes. So factorial makes a difference because 3 is not going to be it. Yeah. If it is 3, we can get 0.3689.
Yeah.
So you have to divide that 0.3689 now by 2 to get the 1.0844. And by divide by 2 because 3 factorial is going to be 3 times 2.
Yeah.
Sir,
So
I
you need-
get the last one, but I
Good
get
job.
0.1804.
Yeah, that needed to. I'm gonna make the corrections to that. Asia, oh yeah, you did say that you get it now when you don't use the parentheses.
But sir, I'm trying the last one again and it's saying syntax. Wondering if I'm putting it in correctly.
All right, try it one more time for me. It's important before I leave because what I'm gonna do is type up the question. I have it written. I'm gonna type up the question and send it off to you. And I want to make sure that you know how to do the stuff. And we can have the conversation over WhatsApp. We don't have to wait until next class. We can have the conversation over WhatsApp. We do it when you get like a free time, and we'll have the conversation. Tell me what to say. Now, Asia.
Still saying syntax.
All right. What are you putting in?
For the
On the
last one,
cap?
I'm putting in 2, the upwards arrow, 3 times shift ln, which gives me
And you put in a -2?
then the arrow again, the -2 divided by 3, then shift the exclamation mark,
Mhm.
then equal and it's a syntax error.
All right. So
Is
then
that
you have
Cassie you have, Asia?
Yeah.
Yeah, it's sometimes, sir. I don't think is that she not putting it correctly, but I get the same thing sometimes. And when I put it in again, I realize I get the answer. I don't know why
Yeah.
I'm doing that.
All right. So let me tell you what I think is happening. Can you put in the first part for me, please? And then press equal,
And then do the
and then put a factorial afterwards. So put 2 to the third times e to the -2 and get equal, and then divide that now by 3 factorial and tell me if you get the answer.
DD, I mean, have the best calculator, man.
E, 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 e. Syntax error for the first part. So when I
For the
put in
first-
when I put in the 2/3 and then all the way to e -2, I'm getting syntax error.
When you put in 2 to the third times e to the -2.
Yeah,
Oh,
that first part.
okay. All right.
I try it too and I get that.
All right. All right. All right. I think I know what is happening. Only positive numbers have logarithms. So because they have that -2 up top there of the e, which is a natural logarithm, I think the calculator is recognizing it as a negative, so it's not going to give you the correct answer. So
Oh,
let me just,
sir.
yeah.
When you're putting in the e, do you press shift to get the e?
Yeah.
I realize when I press alpha instead of shift, I get the
No, it's
answer.
supposed to press shift.
When I press alpha instead of shift, I get the answer. When I press shift, it gets syntax error.
Oh, so it's alpha. Okay, so go ahead and press alpha then. But
Yes, I
but
just got.
all right. Try it this way too. Let me put this one this way in red. Try it this way. 2 to the third divided by e squared.
Oh, sorry, the e's are different. When I press shift, the e is like a regular e, but when I press alpha, it's like a curly little e thing.
Okay, all right. So you have to press alpha then. On my, let's see. Okay. Okay. All right. Yeah. So when I press 1e. All right. So when I press the e to the x is a common e, but when I press alpha e, get a capital E, right?
No, they're both common e's. Just one e looks different, like a different font.
Mm-hmm. But you know,
Mine is a summation sign here mix up in Asia.
Not
no
the
man,
x one.
no man. It's so on the calculator you have the ABC because clearly her version is it the 570 that you have Asia, the Casio 570 FX 570 MS?
So we
That's the one I have there.
The one of just look at the top. Just look at the top where it says Casio. Or that's
I'm
the one
seeing-
you have.
I'm seeing Cassia FX 82 MS.
It's 82 MS.
I have
you have the
570 MS.
You have the 570 MS. All right. So those calculators, both of those calculators can evaluate integrations, the calculus, differentiation and integration. So that's why you're able to do the alpha ABCD right down to Z. All right, because my calculator can also do that. But I'm not a fan of the Texas Instrument, so had one, but still have it. Don't use it, but you should also have it. So what we're saying is we're not going to be using the alpha one. All right, let me see. Somebody does send a picture of it. Right. Yeah. 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 There you go.
Yes, sir. So both e's are different.
Both E's are different. Yeah. So I'm happy that you. But try this way. Don't tell me if well, then again, it won't make no difference because I mean it's the same. We'll find out what the difference is. The E's. All right. All right. I'm gonna end here. What I'm gonna do, I'm gonna type up. I'm gonna send this off to you. I'm gonna send this off to you now, and then I'm gonna type up so you can have another read. Save as so you can have another read through it, and then what I will do is so okay. Hey, them something sensitive, man. Jesus. Very sensitive.
Sorry, so when you have a calculator will never stay wrong, and you go search, you have to go back to it, man. Texas never stay me wrong.
Okay. I am not a fan of Texas.
It's tricky if
Jeez.
you don't understand it.
Yeah.
Yeah, it will lead you astray.
Is it a graphing calculator you have?
No, man. I was bad up and say I should not get a graphing calculator.
Okay. I'm trying to send you this document before I leave because me feel like I go sleep. All right, so I sent you the document that the notes that I prepared for you. The document. I'm gonna add something more to it, the questions, to the document. But I just want to give you that so at least you can read through and put this stuff on. All right, so we look at two distributions now. The binomial and the Poisson. And what I'm going to do is see if I can find some questions. I can look for the questions and the solutions as well. And do the solutions to the questions. So at least you can see how those are worked, and then you can just go and practice on those. And then remember, guys, we're going to keep the communication going in the WhatsApp group, and then we're going to have our they call it our mid-semester, and just a little bit of top up. Anybody knows what day is the exam?
The 7th, I believe.
Whoa, early.
No, the Thursday. It's the Thursday
It's the
after
Isn't
9th.
that the 9th, I think?
nine.
The
The
9th.
9th.
Yeah.
Yeah, we have built environment, building the day after law. So Monday is law, then Tuesday, and then you on Thursday.
Okay, so that means you have Wednesday free then.
Yep.
Okay, so worst case scenario, maybe we can, do a thing or I can just go on a bed. All right, so it sounds good. I mean, you should be fine. So okay, so that means I can mark off the environmentals. That's first then, because I think that will be my first exam, because I think my other exams are in the teens. All right, guys, with that said, the EducaSoft has to be completed. You want to see it quick and fast? EducaSoft has to be completed. And completing the EducaSoft will also help you in your preparations. So please, do what you need to do. All right. Big up on yourself later.
Sir,
Yes,
I'm not sure if anybody mentioned this in this class, but some of the questions, I know we've been through it early on, but some of the questions, they're still giving us wrong for the right answers.
Yeah, that means I say because are frustrating.
Don't worry about it. Do me a favor. And I know Michael sent me something. If you send me something that I can look at. So
I sent you some pictures already early on
right.
in the semester.
Yeah, man. So let me just explain what is happening here. Is it because it's statistics and you don't get rounded values, you get decimals? Put it this way, I think this is the best explanation. If I have a credit card bill and the credit card bill says I'm supposed to pay $150.51, but I went and paid $150.50 and I owe them 1 cent. What do you think the bank is going to do?
Charge your interest for no 1 cent.
Absolutely. Yes. And then now you can cuss and complain and say, Ray, support and so on. Your water rate. If you don't use online banking where you can transfer the cents, and say your water rate comes to whatever, and you pay them $1 and there is 5 cents that is have no more, and you barely find a coin and get that 5 cents, they are going to charge you the $250 for late payment or for underpayment, kind of a pay the bill in full, because it is computer generated. What is the point? The point is the answer is not incorrect. So that's why I want to see the stuff. If you put in 2 decimal places for the answer, but they want 5 decimal places, Send me the information. Once I see it, I can go and I can add the stuff for you. So you don't need to frustrate yourself. I don't want to sit and frustrate yourself. Complete the questions. So just send me the stuff, and I can go and I can amend, and I can ask them to say in the question, specifically how many decimal points to leave the answer to. So that is the main issue. That's the main issue. But I can get that remedied for you. Anyhow, all the best. Dear guys, take care.
All right, sir. Yeah.
Yes.
Nice work.
Yep, yeah. Rockstone, who is we American? And I missed all of this.